All right, so now we go on to something a little bit more high level. So there's a lot of different low-level image processing algorithms like that you can just use, kind of like blocks, plug and play, kind of like that. And you can see that you can think of these as blocks in a diagram, nodes in a node graph, and you can connect them all up, which is pretty cool to think of them like this, just these functions as inputs that process the image. You process the image and then you output to another piece of the algorithm, and you can sort of chain them to give you different things. But so that's low-level image processing. We can go a little bit higher level and start thinking about things like feature detection and corner detection and that sort of thing. And this is useful for understanding how augmented reality works, right? So if you wanted to find where the ground plane is, one thing that has to happen is you have to find a bunch of good features in the image that are stable, that are interesting, and then track them as you move the camera around, and then fit planes to it to sort of understand where the ground plane is. And that's how sort of some SLAM algorithms start. So you take some good features and then you build on that. So one of the basic pieces of that is understanding features that are important. And in imagery, what we find is good features are things like, at least there's a few different definitions of good features, but the most basic form of good features is what's called a corner. And a corner is where you'll notice in an image, where you have a high change on the X and the Y, a very high value of change, right, between the X and Y in a small window around that pixel. And so if you take a look at a sort of in the top range here, for every pixel around here, if you look at its neighborhood region, there's no change. And so if you were to subtract the neighborhoods in front and behind you on both X and Y, you'll see that there's no change in value. And so those aren't very good features because they're everywhere and they're very flat. But if you have something like this where you have a change in X and a change in Y, then you can say that that's a corner, right? So what is done usually is they take what's called a Lucas-Canetti or a Harris corner, and there's a different algorithm to do this. And there's a function in OpenCV called good features to track, which does this for us. And basically, we give it some values, some threshold values, etc., that we can tweak, and it will output a bunch of corners that we can use in our imagery. And we can then use these corners to do things like tracking an object over time, or using them as input to estimate 3D structure, or matching features, matching targets between two images, to do calibration of cameras, etc. So there's a lot of neat things and a lot of research that goes behind these types of features and how to define them. And these are sort of the original basic features, and there's some really good algorithms afterwards called SIFT or SURF, and then beyond that are used more often because they provide even better quality features. But this gives us a good start to sort of understand how we might extract and use different types of features. So we want to be able to call this this function, good features to track. And yeah, so we want to basically do something similar to what we've done with erosion and dilation. We're going to call this function and we're going to display the features in our image. Okay, so let's do that. So let me comment out what we've done so far. Okay, because I don't think we need that. We might need it later. Okay, so basically what we're going to do is we're going to do something very similar to what we did before. We're going to have a window, we're going to have a function that is global, and we're going to have some track bar threshold values. Okay, so we are going to need to call a function. Let's do feature detect, right? Let's call it feature detect. Kind of like what we did for the erosion function. That'll be a global function. Feature detection works, especially good features, only works on grayscale images, so we have to convert to grayscale first. And we've done this for our grayscale imagery up above, our thresholding, right? Color BGR to gray. Cool. And we need a source gray frame color. Okay. Okay. So this is what we have. We need a grayscale image. We're going to say create a track bar. And the track bar is going to say the maximum features to keep, because you can do like the algorithm will give you many, many, many features. We're going to display this on our live feed, or just a regular feed. We need to pass the max number of corners. This is the value that we get back. Max features. Let's call it max features. Count max value. And then our callback, which is our feature detect function. Oops. Okay. So I need to have feature detect and max features. Let's do it up here. Features. So we need to have max features. What should be a good number? 200. We're going to need to have feature detect function. Void star. We don't care about them. Oops. Okay. Not I. Feature detect. Okay, cool. All right. So inside feature detect, what do we need to do? Well, we need to call good features to good features to track, right? Good features to track, which has a lot of parameters. So let's do them one by one. We need an image, an output array of corners, maximum corners, the quality, the distance, mask, block size gradient, Boolean, and a value. We'll see what all those mean if we look down here. Okay. So the image is going to be our input image, right? It's going to be our source gray, right? That's our input image. We're going to need to have something to store our corners, and that will be defined here. Our corners are just going to be a vector, standard vector of points, 0.2f. This is an internal type. So it's a vector type, standard vector, so it's a list of points, 2D points. Quality level is next, right? Quality level, minimum distance, min distance. What else do we need? Mask, which can be just empty. Block size, gradient size, and Boolean to use Harris detector, which we can set to true or false, and a value, a double value k, which is just a parameter for quality. And let's define these all here. Okay. Max corners, double quality level. Is going to be some small number, 0.01. Minimum distance, let's say 10. Let's change these. Block size should be odd. It's going to be the window size. Gradient size. Gradient size is the size of the window to use to compute the gradient or the change in the neighborhood region. Bool, use Harris detector. False. Double K equals 0.04. Okay. That should be it. I don't know why it's complaining. Why is it complaining? Didn't like that. Good features to track. Okay. Image, max corners. Well, image corners, max corners. Image, corners. Max corners. We forgot one. Max corners. There we go. Okay, max features. All right. Cool. All right, so here we should be able to compile. Let's just make sure we compile and then we can use them. Okay, good. So running this will give us, will basically give us corners in this image. Now, one thing to note. Okay, so what we have to do now is let's draw these features. And for, let's say, size ti equals 0, I less than corners.size, so the number of corners. So let's go through for each corner, right? Oops, underscore t. Okay. Could be int. So for each corner, oops, if I could type today. Okay, so for each corner, what we want to do is we want to draw a circle. Okay, luckily OpenCV has a little function called circle, and this draws a circle in an image. Okay, so this will draw a circle in an image. We're going to draw it in a separate image. Let's do copy, and we're going to do that copy is equal to source gray.clone. Okay. Okay, so we're going to draw into copy. We're going to pass it the corners, the current corner, right, the center of the corner, the radius of the circle, and then a CV scalar, which is a scalar. We can give it a random number. Luckily, we can create a random number. We'll see this in a second. We'll create a random number up above here. Random number generator. 1, 2, 3, 4, 5. Just an array. Okay. And we can say RNG dot uniform random number. Why is it arrow? It should be dot. Okay. From 0 to 225. Cool. Oh, it's not an array. Sorry. Just initializing with a seed. Okay. Okay. And then we'll do that for all three values for red, green, and blue. Red, green, blue. Okay. Cool. Thickness. Filled. We'll say 1 and 8, sure. Thickness. Oh, I'm going to say filled. Okay. That's defined. Okay. Because it says so here. Type. We can use a type. We just end it there. Use the default values of that. We need a radius. So int radius. It's a radius number of pixels. Let's say 4 pixels radius-wise. Okay, so that's going to draw a circle at every corner that's found. Cool. And then we should draw this this window. Image show features. Copy. Named window. We don't need to do this, but features. In case that nothing's found, we'll draw it anyway. All right, let's see what happens. All right, let's see if we've done this correctly. And if we have, we should see corners. Ah, cool. Yay. Max features, right? Okay, so I can move the number of features down to lower and lower. Oh, yeah. So I put this in my live window. Cool. Okay, so that's cool. So it's generating a random number every time, which is why it's flickery, but that's cool. So you can see they're fairly stable, right? And if you did this on the thresholded image, you can get rid of some flat regions first and some crappy regions first. But this could be used to track things, to track features. So like you can imagine initializing this, tracking features. Take a look at the corners. It's very stable with corners. So take a look at my doorway at the top there. The corners of the doorway, as I move this, it actually does quite well. If you were to initialize a tracker for each one of these and just feed it into tracking these, you could track planar regions and prune features that don't conform to a plane and just keep planar regions, and that's how AR tends to work, right? You can fit a 3D plane to it, which is neat. So, and you can see my fingers, sometimes they get in the corner regions. What about if I were to look at, let's say this, right? Or let's do a painting here. Let's see what happens. Yeah, finds the corners of the painting quite well, right? Kind of cool. Cool. And what about a can? Club soda. Notice it doesn't work so well with specularities because specularities are hard in general. What about a marker? Yep. Cool. Neat. So that is good features. All right. All right. On to the next video.